Start by taking the handout that you picked up and folding it into a booklet with this as the cover where it says Classifying Numbers, Part 1, Rational versus Irrational. So this objective is very different than our past objectives, which is this objective is more about information that you need to know as opposed to a skill that you need to be able to do. So I've included all the information here. I'm going to read through it quickly with you, and then you're going to try and see if you can apply it. So first, all numbers that you've experienced so far are real numbers. Real numbers can be rational or irrational. So basically, we're going to just, when we say real numbers, we mean numbers. There is such thing as an imaginary number, but you haven't learned about it yet, and you won't just come across it randomly. You'll see it in Algebra 2. So when we talk about all numbers, we say real numbers. Okay, then we divide real numbers into two different categories, right? Some are rational and some are irrational. So let's start with rational. Rational is a number that can be made by dividing two integers. So remember, integers are numbers with no fractional parts, so integers can be like -3 or 0 or 10, right? But they can't be like 5.5 or anything like that. So an example of a rational number, 1/2 is rational because it's just 1 divided by 2. 2.12 is rational because it's 212 divided by 100. -6.6 is rational because it's -66 divided by 100, right? And so you can see that rational numbers, they can be decimals, and 0 is also rational. The square root of 16, right? Remember, the square root of 16 is actually just 4, so that's rational. That's just 4 divided by 1, right? And so the way that you can tell a number is rational is any number that is not a non-ending, non-repeating decimal. So, right, decimals are okay. Negative decimals are okay. Even repeating decimals, like, for example, 5.2 repeating, that's rational, right? That means 5.2222222 forever. That's rational. So as long as they're not non-ending, non-repeating decimals, they're rational. Okay, so that includes decimals, fractions, whole numbers, negative numbers, and square roots that equal an integer. So for example, right, 16, the square root of 16 is 4, that's an integer. Now, irrational numbers is a number that cannot be made by dividing two integers. Now, there's some pretty specific examples of irrational numbers. Most numbers that we work with are rational. Those are the numbers that we see all the time. So irrational, there's just a few specific examples. Pi is the most famous irrational number. That's a decimal that goes on forever. It doesn't repeat, and it doesn't end. Okay, so pi is the most famous. Another irrational number, the square root of 2. Why is the square root of 2 irrational? Well, because if I put the square root of 2 in a calculator, I get a decimal that doesn't end and it doesn't repeat. So it starts off 1.4142, and then it goes on, and it doesn't repeat at all. And so that's a square root that doesn't equal an integer, right? The square root of 16 is just 4. So that's rational. The square root of 2, it doesn't equal an integer. What it does equal is a non-ending, non-repeating decimal. That's irrational. Same with the square root of 18, right? If it doesn't equal an integer, then it's not rational. Same with the square root of 90, right? So irrational numbers is pretty much just two things. It's pi, and then it's square roots that don't equal whole numbers, right? So let's consider, like, what's the square root of 49? Is that rational or irrational? Well, that equals 7, so that's not irrational, right? The square root of 49 would be rational. But what about the square root of 50? Well, the square root of 49 is 7. The square root of 50 might be close to 7, but it's going to be like 7 point something, 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 something forever. So the square root of 50 would be irrational. Okay, so how can you tell it's irrational? It'll be a non-ending, non-repeating decimal. Okay, and the two types of numbers that will get you the non-ending, non-repeating decimal, two things, pi and the square root of a number without an integer square root, right? So any of these are examples. Most numbers are examples, right? So the square root of 10 is irrational. The square root of 12 is irrational. The square root of, right, so like 9, that's rational because that's 3. But 8, no, that's irrational.